this is our initial pressure, which is 1.5. So we have to identify the pressure, and we have the initial dryness fraction, which is 0.8, and we have the final pressure after throttling is what? It is 0.12, and it will be equals to 1.2 bar. So let's take a look and see the 15 bar. Where's 6, 15, 15, 15? So this is 15. At 15 bar, the value of the H of F will be 845, and also the value of this, which is the H of Fg, will now be what? Will now be 1947. And also, so as you can see, you have to take note of the value of H of F, and also what? And also the value of H of Fg. So therefore, let's write the values down and continue to the solution. And continue with our solution. So let's take a look and see the 15 bar. Where's 6, 15, 15, 15? So this is 15. At 15 bar, the value of the H of F will be 845, and also the value of this, which is the H of Fg, will now be what? Will now be 1947. And also, so as you can see, you have to take note of the value of H of F, and also what? And also the value of H of Fg. So therefore, let's write the values down and continue to the solution. And continue with our solution. So, since the throttling is an isenthalpic process, H1 must be equals to what? Must be equals to H2. So, I'm first going to find the initial enthalpy from the steam table at 15 bar, because this 1.5 will now become what? Will now become 15 bar. So I'll have the pressure after converting it, which is 15 bar. You have to take note of that. Some of the pressure are in kilonewton per meter square, some are in mn power per meter square. So you have to take note of the conversion. So this 1.5 should now change to 15 bar. So from the steam table, we are going to find the H of F, and also we are going to find the H of Fg. So let's take the steam table and see. Where's 6, 15, 15, 15? So this is 15. At 15 bar, the value of the H of F will be 845, and also the value of this, which is the H of Fg, will now be what? Will now be 1947. And also, so as you can see, you have to take note of the value of H of F, and also what? And also the value of H of Fg. So therefore, let's write the values down and continue to the solution. So as you can see, the H of F, it is what? It is 845 from the steam table, and also this is 1940 what? 1947. So since our dryness fraction, it is what? X1, it is 0.8. So therefore, I will say X1, it is 0.8 here. So the next thing I will say, my H1 should now be equals to, I will have the H of F plus what? Plus XF plus X1. Yes, X1 H of what? H of Fg. So this will now be equals to our H of F, which is 845, and therefore plus the dryness fraction. So I will say 0.8 multiplied by the H of Fg, which is what? Which is the 1947. At the end, let me see what should I going to get. So at the end, I will get 2402 point what? 0.6 kilojoule per watt per kg. So, and therefore H2 also will now be the same thing, which is 2402.6 watt kilojoule per watt per kg. So the next thing that I'm going to do here is that I have to next find the dryness fraction after what? The dryness fraction after throttling. So let me do like this. Let me say the dryness fraction after throttling, but I'm going to find the I'm going to find my h of f and h of fg at what? At 1.2 bar, because this 0.12 bar, after converting it, it will now become 1.2 bar. So I'll find in what? 1.2 bar. So I'll check my steam table under 1.2 bar. And what shall I going to get as my h of fg, which is the enthalpy. So let me check for h of f and h of fg. So also for 1.2 bar, as you can see, also for the 1.2 bar, as you can see, this is 1.2 bar. So I'll first take a look. This is my 1.2 bar, and this is h of what? H of f. So I'll come across to the third line. So the h of f will be 439, and therefore the h of fg will be 2244. So also I'll pick those values, h of f and also the h of what? H of fg, which is 224. So as you can see, h of f, it is what? It is 439 kilojoule per hour per kg, and the h of fg, it is what? It is 2244. And the next thing that I'm going to do, I have to say the h2, it should now be equals to what? The h of f plus what? Plus the x2 h of what? H of fg. So you have to take note that I already have h2, because I say this h1, I said h1, it is equals to what? It is equals to h2, because since the throttling is an isenthalpic process. So I'm looking for x2 now. I'm going to find this dryness, so I need some space. So I'll now say what will be my h2. Okay, sorry, I delete it, but it is what? It is 2402.5. it is equals to what? It is equals to 439, which is the h of f, and plus what? Plus x2, because I'm looking forward for the x2 multiplied by h of fg, which is this, which is the change in h of fg. It means hg minus what? Minus hf. So which is, let me open the bracket and I will say 2244. So the next thing that I'm going to do here is that I'll keep my 2402.5, and therefore this 439 will now cross the equal sign and it will become negative. So I'll have 439. So therefore this will now be equals to, and again I'll say if I multiply this and this, I'll get 2244x2. So I'll subtract this. If I subtract this, I'll get, oh, I should just divide both sides by what? By 2244, because I'm looking forward. I'm looking for x2, 2244. This will go with this. At the end, x2 will now be equals to 2402.5 minus 439. Divide it by 2244. So what should I going to get? So this should now be equals to x2 will be 0.875. So this is my x2. We are to determine the dryness fraction of steam after throttling. So I will now say therefore x2, it is 0.875 after throttling. So this is the end of this question.